So we're going to work on the assignment that will open a file and build a dictionary that is a frequency count or a histogram of the letters in that file. So if the letter A occurs in it 27 times and then the letter B occurs in it 10 times and so on, we can collect that data. Then the second part of the assignment is to draw a bar graph based on that data. So to do that, what we did previously in the semester is we cooked up a drawbar chunk of code. So what we will need to do the drawbar is a function that looks something like this. In fact, this is, the code that we used. And the three parameters are height, width, and spacer. Yeah, we could have given them better names than height, or H, W, and S. We could have called them, height, width, and spacer. I'm not going to go in rename all of these. I think I'll post the code for drawbar as one of our notes in contents. Maybe I'll just go ahead and, I'm going to undo that change. Just know that H is for height, W is for width, and S is for spacer. That's the distance between the bars that we're going to draw. That's how wide the bar is. And that's the height. Now to set this up, we need to create our turtle. So let's do that. I'm going to create a section called main. It will look like this, where we import the turtle. We create it, t is equal to turtle.turtle. We get our window, wn is equal to turtle.screen. We speed the turtle up with t.speed0. We hide the turtle, and we're going to set the color of our turtle to blue. Okay, that will also be included in the demonstration code. A couple of more things that we're going to do is we're going to try to get our drawing to start at the left end, the left side of the screen. So we're going to add a few more lines of code that do that. We're also going to define the width of each bar and the width of the spaces between the bars. So W is equal to, we're just going to call this width. Width is equal to 40. Spacer is equal to 10. And we need to move our cursor back, our turtle back at the beginning. So I'm going to do this. S width is equal to wn dot window underscore width. That gets the width of the window in pixels. And then backspace is equal to S width divided by 2 minus the amount of the spacer, because we don't want to be quite back against the edge of the screen. We want to give ourselves a little bit of space. We'll be able to change the width in the spacer all we want as we play with it to make sure that our output looks good. After we have set our values, we need to actually perform the backspacing. T.set heading 0, T.pin up, T.back, the amount of space that we need to go, backspace, and then T.pin down. Then we're ready to call drawbar. Let's give it a try. Drawbar, and let's make our first bar 20 pixels tall. What's the width? What's the spacer? And then let's draw a second bar that's 10 by the width and the spacer. And then lastly, after our drawbar calls, we're going to do wn.mainLoop. That sits there and waits for the turtle to be done. So we're going to save our code. I'm going to call it letter graph. And I'm going to run it, hope it works. I'll probably have a few syntax errors. And it actually did work. If we come in here and we look, we have a bar that's 20 tall and one that's 10 tall. Now when we print out our letters, we're not going to only want to print out the height, we're going to want to print out the letter itself. You know, that A was 20 and that B was 10 and so on. And since there are more than 26 letters, we're probably going to need to make the width of these a little bit narrower. For example, what if we had more bars to draw? So, you know, what if we wanted to draw one more bar, and then another? What I did is I just cut and pasted it. So we run it. There's what it looks like. But we can make these bars narrower, a little bit narrower. Let's do that. Maybe a width of 30 and a spacer of 5. And we can play with all we want once we got our dictionary going. But maybe that looks pretty good. You know, and it's looking differently on mine. It runs it with a certain width. When you run yours, it may wind up being wider, and you can always widen your window to see the whole graph if it's not shown on the screen, you know, like that. Sure, it's, you know, got that space there. But we'll keep playing with the spacing later. So we have some code that draws a graph. I'm going to comment this stuff out, right? And I will have already given you all the code from here to here. But here's where it's going to start being different. We need to also pass in what we are printing. I'm going to uncomment these things. For example, this may be the number of x's. So we want to be able to pass in like something like that. And this may be the number of y's. This may be the number of a's. This may be the number of c's, you know, something like that. We would have to modify our drawbar function to match. So we're going to add a parameter to it, text. And when we write out, here's our line write. When we display the value, let's also display the text. So we're going to change that line that says write. We're going to replace that H, or we're going to add to it. Here's what we're going to do. What we're going to write out is the text plus a colon plus a string representation of the height. Let's see if that works. Okay, that's looking pretty nice. We have 20 x's, we have 10 y's, we have 30 a's, and we have 50 c's, and so on. Okay, so I consider our graphing portion set up for us to use later. Now the problem becomes we want to build our frequency count, right? We want to create our dictionary full of the letters and the number that they occur. So I'm going to push his drawbar code all the way down here for now. What does our code need to do? Let's put some guideposts here. Well, let's put our name here, you know, my name, and so on, all the rest of this stuff. So our program needs to ask the user for a file name. Needs to open that file. Needs to create an empty dictionary. It needs to read the file. Adding each letter found to the dictionary. Now this is a little bit nebulously worded here. Adding each letter found to the dictionary, or adding one to the count if it's already in the dictionary. Why is that? Because a dictionary is a series of values. I mean, a pair of values, a key and a value. So the first time we find an A, the key is going to be A, and the count is going to be 1. But then the next time we find an A, the count's going to change to 2 and 3, and so on. And then we say we find a C. There's going to be one of those. Then we find another A. we add 1 to that. And then we find another C, and we add 1 to that. And eventually we'll have a dictionary that contains all the letters that are in the file. So that's going to be that step. Then we're going to close the file, and then we're going to draw our graph. So asking the user for a file name, opening the file, that's pretty easy stuff. File name is equal to input, open what file, question mark, like that. Now we're going to open it. File is equal to open that file name for reading. Then what are we going to do? Well, we need to read the file in. And there are plenty of ways of reading the file in. And I know that I've demonstrated, more than one way in class. We're just going to pick one and go through it. Go for it. But we need to create our empty dictionary first, because that has to be done before our loop. So I'm just going to call it letters is equal to dict, D-I-C-T. That creates our empty dictionary. So we have our file. We can do this. For every line in the file, for line in file, we want to do a few things to that line. We want to strip out any carriage returns and stuff like that. So we're going to say that line is equal to line.strip. And then we want to process all the letters in that. But let's take out a few things from the file. Let's say that we don't want periods or commas or question marks or exclamations. Let's make a string called skips. And we're going to put everything in here that we don't actually care about. We don't care about periods, question marks, exclamations, semicolons, colons, spaces. None of that stuff do we want in our final graph. We only care about letters and numbers. So now we need another loop that's going to process that line. We need to go from the beginning of that string to the end. So let's just set up our typical for loop for I in range up to the length of the line. Okay. And if the value is not in the skips list, we're going to add it to the dictionary. So let's go ahead and get our character. Character is equal to, the line at that position. Now let's see if that character is in skips. If character not in skips, great. We have some valid data. We care about it. Add. If the value is in the dictionary, add to the count. Else, add it to the dictionary with a count of 1. So if that character is in our letters dictionary, if CH is in letters, that means it exists. We're going to get the count out, and we're going to modify the count. Count is equal to letters using that character as the key. Then we're going to add 1 to our count, and we're going to put it back into our dictionary. Letters CH is equal to count. But if none of that was true, if we didn't find it in the dictionary already, we're just going to put it in there right now with a count of 1. So I hope you can see that each time we get the character out, If it's not in our skip list, we check the dictionary. If it is in a dictionary, we get the count of how many times we found it so far. We add one to it, and we put that back into the dictionary. Otherwise, we put it in the dictionary with a count of 1. I think that's the end of the end-if. I think that's the end of the for. And I think that's the end of that for. We need to see if this works. We need to see if our code works. I think I'm going to, I'm not going to change anything. But I am going to print our dictionary out. This is a temporary fix. We're just going to print the whole dictionary out to see what it looks like. All right, so I hope this makes sense. I'm going to take some of the white space out so we can get it all on the page at the same time so you can pause and look at it. All right, let's run it. Let's see if it does anything good. The only problem is that as soon as we do it, it's going to draw our graph full of meaningless data, but that's okay. We'll see if it works. Open what file? Well, why don't we, you should make your own test file perhaps, but I'm just going to use our Python file as our test file because our Python file, lettergraph.py, has, plenty of letters in it to count. So I'm going to use the name of our program itself. Open what file? Lettergraph.py. And it did work. It counted how many 5s did it find? It found 2. How many I's did it find? 77. How many dashes did it find? 1. How many underscores? 3. We could add the dashes and the underscores and the semicolons to our ignore list if we wanted to our skips list. But just eyeballing the dictionary, I'm assuming it's working. If your output looks anything like that and it didn't crash, it worked for you. You can test it on a smaller file, something that has something like the quick brown fox, whatever, just a paragraph of text so that you can eyeball it, make sure that it all works. Okay, so now we want to actually print out the dictionary in a better format than that. So what we're going to do is for every key that's in the results dictionary, we want to print that key out. Each letter is only 1 character wide, but then the count might be several characters wide. Right? But I'm going to assume that it's no more than 4 characters wide. So %4D. And we need to pass in some stuff to print out. So for every key in the results, our value is equal to results key, because the dictionary is composed of keys and values. And so then we're going to print out, using %S and %4D, the key and the value, like that. And then let's tell the user to hit enter to see the graph. Now let's run it. Same deal. I'm just going to open our program file again. Lettergraph.py, whatever you called your program. Ew, results is not defined. Well, of course not. What did I call my dictionary? I gave it a completely different name. My dictionary was called letters. So I need to change my loop here. For every key, for key in letters, value is equal to letters, square brace, key in square brace, and then print it out. And hopefully no more typos there, no more syntax errors. What file? Lettergraph.py. And there we go. We get our cute little chart. How many T's did we find? How many V's? How many H's? How many M's? Now, if we really wanted to, we could try to print this out in alphabetical order, but I'm not going to bother doing that. That's difficult. I didn't ask for it in the assignment. So the last thing to do is to iterate through our letters dictionary, drawing the graph. So we're just going to do the same kind of thing, except instead of just printing out the value, we're going to use the key and the value as the things that we pass to our bar graph function. Okay. I'm deleting a whole bunch of stuff that I don't need to. Alrighty, so there's our drawbar code. I'm going to scroll all the way down to here. And where we have some stuff, some test calls to drawbar, that's where we're going to actually put our code. So for every key in our dictionary, for every key in letters, I called it value last time, but I could call it count, you know. In fact, yeah, count is equal to letters to the count that's associated with that key. And now let's call drawbar. What's the letter? That's contained in the key variable. What's the count of the letter? Count of the letter is in count. What's the width? In the spacer. And we are actually done with the program at this point. Well, I say that, but there may be a few more changes we want to make. We'll see. Lettergraph.py. At the bottom of this, it says press enter. Not that you can see it, but it does. Press enter to see the graph. I hit enter, and it draws our graph like that. And does it look absolutely perfect? Could we make the bars a little bit narrower? Could we add some things to the skips? I think we could. I am going to make the bars a little bit narrower. So the width of the bars is going to be 20. Let's run. Lettergraph.py. Hit enter to see the graph. And there's our graph. Stretch it out, we can kind of see it. It's okay if we can't see all of it, really. Kind of a side effect of how many things we need to print out. Oh, I see a change that I want to make, though. This is counting uppercase letters and lowercase letters differently, you know. So let's make a modification so that, well, let's add a few things to our ignore list, like underscores and dashes and equal signs. And then let's make it so that we only do uppercase letters. So I'm going to scroll back up to here. And after we get the line of data, after we strip the line of its blank spaces at the end, we're then going to convert it to uppercase. Line is equal to line.upper. You see where we made that change? Right here after the strip. That's where we're putting it. And equal signs, dashes, underscores, pluses, commas, parentheses in parentheses, square brackets in square brackets. Our data should look a little bit clearer. Open what file? Again, lettergraph.py. Hit enter to see our graph. And if we stretched it out enough, we could probably see the whole thing. Yeah. I thought I added parentheses to our ignore list. I thought I added colons. I thought I... And number signs, were they not in there? I'm not seeing why that's not working. I'm going to run it once more just to watch it go. Okay, we're going to change this check here. I know that that works for lists. It doesn't seem to be working for strings. So that line that says if ch not equal skips, that is what we're going to change. We're going to do if skips dot index of, with a capital O, ch is greater than or equal to 0. That's what we've changed it to. So I'm running it again. What file? Letter graph.py. Hit enter to see the graph. Ooh, and it crashed. That was not a good change. I need to pause the recording, find the change that I want to make, get it working, and then unpause it. So you don't have to see me fumble with this. Alrighty. I'm still managing to confuse myself. I got it to work by something that shouldn't have made it work. I'm going to make a change here, and if it doesn't work, then forget it. We're going to call it done anyways. We're going to change the logic of that statement. I'd already undone it by the time you got here. So after ch is equal to line subscript I, if ch is in skips, if ch in skips, let's just print a little message. Skipping, end quote, comma, ch. Then backspace else. That way we'll get to see what characters are actually being skipped. Periods, question marks, exclamation marks, semicolons, colons, equal, minus, number signs, parentheses, curly braces, square braces, forward slash. And that'd be enough, huh? So, letter graph.py. It's showing me that it's skipping a lot of stuff. And this time it actually worked. Yeah, I see a few things that I didn't want to see. I see, looks like an underscore. And a plus. Maybe those weren't in our skip list. A percent. I'm kind of leaving the idea of percent alone, just for reasons I'm not going to explain. I don't have a plus in my skipped list. Apparently I don't have an underscore. Okay. So I don't know why putting it in the form of if-else made the improvement, but it seemed to have. I have no idea. I'm not going to worry about that anymore. It is working at this point. There's all the numbers, all the letters it's skipping. Here's our final output. Let's hit enter, see our graph. Yeah. And it's working. We have a pretty graph. Okay, I'm going to put the code on screen so that you can compare yours, make sure you have it working. And we'll call this done.